and today I'll be covering clouds and precipitation. So the formation of precipitation, how does it come to be? The sun warms Earth's surface, and then heat and water vapor are then transferred into the atmosphere. And since the water vapor and the heat are warmer than the surrounding air, it rises and cools. And then it eventually cools to such a point that it undergoes supersaturation and turns into either liquid or solid form, which would be either rain or ice or snow. And then condensed particles collect and they become visible as a cloud. And then particles combine and possibly fall completely to Earth's surface. Some may not make it all the way. And the difference between rain, snow, sleet, and hail depends on how cold the water parcel gets following supersaturation. So if it just gets cold enough to cool and collect as water droplets, then it'll fall as rain. But if it gets cold enough to completely freeze and fall as ice, then it would go all the way up to hail, with snow and sleet being somewhere in between. Airlifting. Airlifting is a very important process because it really makes precipitation possible. Two kinds of airlifting. One is orographic lifting. This is where a mountain acts as like a barrier or a wedge with wind blowing on just one side of the mountain, and it causes the wind to kind of use the mountain as a ramp, the warm air to go up the side of the mountain and rise, causing it to cool and eventually cause precipitation. Meanwhile, the other side of the mountain is kind of blocked from all of this, so only one side really benefits from all the precipitation and wind. Another kind of airlifting is frontal wedging, and this is what we experience in Oklahoma a lot. It's where masses of cold and warm air collide, which the warm air being warmer than the cold air obviously would go and start to elevate, and it would force the warm air to rise, and then it would eventually cool and produce precipitation. And that is, once again, a lot of where Oklahoma's precipitation comes from, is the colliding of cold and warm fronts. Lastly is the adiabatic cooling process. It's a relatively simple process where water vapor just eventually turns into precipitation. Air pressure decreases with altitude, so it starts on the ground, and then as it evaporates, it will continue to elevate, and we'll get into less high pressures, and the vapor will be able to spread out a little more as it continues to elevate to a point to where it'll eventually cool and condense and will then collect into clouds. It'll cool at about 5 degrees per every 1,000 meters, 5 to 10. And then as it collects into clouds, it'll continue to condense more and collect more, and then it'll eventually precipitate and possibly fall all the way back to Earth's surface.